out of this problem entirely because it doesn't participate. It is a spectator, and we're not messing with it. All right, next. This is the more difficult version, okay? First thing that you have to do is actually pick out what's important. All right, we can see here that we have permanganate, potassium permanganate on this side, and we have MnCl2 on this side. Manganese loves to participate in redox, so we should probably check and see what its oxidation numbers are. Potassium is always +1, oxygen's always -2, so -2 times 4 is -8. Potassium's +1 means that the manganese right here is a +7 charge. We go to the HCl. That's a +1 and a -1. On the other side, we have chlorine gas. That's elemental, so that's a 0. Manganese chloride. Chloride is a -1 here because it's in its sort of standard form, meaning 2 negatives, Mn has to be +2. Potassium is +1, chloride is -1. Within the context of water, oxygen's -2, and hydrogen is +1. So now we have to see what changed. And from that, we have to pick out only the important parts. And to be an important part, it has to be the element or part of a polyatomic ion. That's how you decide whether or not to keep it. So if we compare the equation in potassium permanganate, potassium stays the same on both sides. So we don't need to mess with it at all. It's a spectator ion. MnO4 is a polyatomic ion, and Mn goes from a +7 to a +2. So we do need to keep that. So that's how we're going to begin our first half reaction. We have the permanganate ion. We don't keep the potassium because it is a spectator. So we do need to keep the permanganate, and then we pair the element that's changing charge, which is the manganese. So the second half of our half reaction includes that. Now we have MnCl2. However, we have chloride is a plus or a -1 here, and chloride is a -1 here. So really all we need is the Mn +2. Our other half reaction has to be based on the other element that changes charge. So if we take a look, it's chloride. It's Cl- from the acid on the left, and chlorine elementally, diatomic, on the right. Everything else that's listed in there just gives us some more information. Another bit of important information that we have is that this is an acidic solution. And we know that because it has HCl. Sometimes it just says that it's acidified. Sometimes it has H2SO4, even though it's not really pertinent to the reaction. Those are all clues. Alright, so the first step we have to do once we get our half reactions is we need to balance the mass, so anything that's not oxygen or hydrogen. In MnO4 and Mn +2, there's nothing else there to balance. Down here for the chlorine, we need 2 chlorines on the left and 1 on the right. The next step is to balance the hydrogens and the oxygens. Since we have an acidic solution, I have 4 oxygens on the left over here. That means I have to add 4 waters on the right. And once I add the oxygens, now I've added hydrogen as well. So now I have to go back to the left and add an appropriate number of hydrogen ions. In this case, 4 times 2 from the water, so 8 hydrogen ions. Looking at the chloride and chlorine, there's no oxygen or hydrogen there, so that's done. The next step is to balance the charge with electrons. So I look at the complete charge on the whole reactant side. I have 8 positives and 1 negative, so that's +7. On the product side, I have positive 2, and this is 0 because it's a molecule, so overall positive 2. The goal is to get both of them to match each other. So in order to do that, I then add in appropriate number of electrons. To get 7 to equal 2, I have to add in 5 electrons. Similar scenario with the bottom. I have 2 negative 1s, so that's a negative 2 on this side. That is a molecule, so that's neutral over here. So I need to add 2 electrons to the product in order to make that work. 2 and 5 obviously don't work together, so now I have to multiply them in order to get an equal number of electrons. In this case, the easiest thing to do is to multiply them by each other. So multiply that entire thing by 2, multiply this entire thing by 5. So I'm going to write them below it so they're easier to see. 2 times 5 is 10 electrons, plus 16 hydrogen, plus 2 permanganate.
Excuse me, Miss. Let's see where we're supposed to put these.
My apology for the interruption there. We're continuing on. So we're multiplying 2 permanganate, 8 water, and then down here we have 2 times 5 is 10 chloride, 5 Cl2, and 10 electrons. Now we can see we have 10 electrons on both sides, so we can cancel those, and then we can combine this back into our single equation. So we have 16 hydrogen ions, 2 permanganate ions, 10 chloride ions. It takes care of that one, and that one. On the other side we have 2 manganese plus 2 ions, 8 water, and 5 Cl2. That one, and that one. Alright, so that becomes our balanced net ionic equation.